Hey, welcome to part 2 of this series. I do recommend that you finish part 1 prior to jumping into this one, but what we need to do here is actually deploy our AI as an API into production using a virtual machine. It's a fairly straightforward process, but there's a lot of things that we need to consider. So let's go ahead and take a look right now. Now we need to pick a cloud provider for our production application. I have 3 criteria for this, but primarily 2. Number 1 is that you have access to a virtual machine. We need to be able to control everything about the environment that our application is going to run on because we need TensorFlow to run. We need to be able to install the version of TensorFlow we want so we can load in our Keras model. The next thing is the ease of use, right? So I want something that's pretty easy to spin up and also spin down so we can, really experiment a lot. And then the final thing is more future thinking is having the access to a GPU. If you don't have access to a GPU, then we won't be able to ever train it on that service, right? So that's why I'm picking Linode as our cloud provider. Now, as far as virtual machines go, we can absolutely use DigitalOcean droplets. We can use Amazon EC2. We can use Google Cloud Compute Engine. We can use Microsoft Azure virtual machines. And we can also even use a Raspberry Pi. Now, it's not a virtual machine itself, but it's a machine that's a lot like what you would use in production on a virtual machine. So for like $40, you can own this device and have the capabilities of running everything we're going to do here, as long as you get one that has at least about 4 gigabytes of RAM. Now, what we're not going to be running on is something like DigitalOcean App Platform or Heroku. Now, those 2 services have a lot of benefits in of themselves, but we are not using them because we do not control the entire environment. We don't control the infrastructure at all. Now, that is one of the downsides of trying to deploy on there. That's why we want to actually get a virtual machine and control the environment from scratch. Now, if that scares you at all, don't worry. It's not actually that challenging to do. There are some steps we need to get there, and that's really the part of what we're going to be doing now. That's why we're doing what we're doing now, is to see how to control some of this infrastructure and to have our application running in production. Now we're going to go ahead and generate our SSH keys. So be sure to open up Terminal or PowerShell, depending on what system you're on, and type out SSH. And of course, SSH stands for Secure Shell. All this means is we can actually call SSH, connect to a virtual machine, whether it's on our local network or on a cloud provider, and we can actually do some commands in there from our local machine, right? Hopefully you've seen this before. Even if you haven't, it's actually pretty straightforward on what to do. So the first thing I need to do before I can use this on a cloud provider is I need to provide that cloud provider with our SSH key. So we'll go ahead and generate one now with SSH-key gen, and it's going to ask you to generate this public and private key pair. I want you to think of this as username and password, right? Private, we never want to share. Username, we can share. So now it's going to ask you where to save this file. Of course, this is going to be updated depending on your system and your username. So just go ahead and hit enter for the default. In this case, mine already exists. I am not going to overwrite this. I will talk about why in a second, but I'll leave that out. Now, if yours doesn't already exist, it's going to ask you to write a password. You can write a password if you want. So let's go ahead and take a look at that. I'm just going to make another one in the same location, and I'm just going to call it delete RSA. Hit enter. You're going to see something like this passphrase. So by all means, go ahead and write one in there. And it's going to ask you again. Now, in this case, I definitely did not create one. But what you see is where it's actually stored. So your identification, the actual private key is stored here, and then your public key is stored there. Okay. So I'm going to go ahead and navigate into my .ssh folder, which is the same thing as navigating to that folder with the tilde there. Notice these new keys I have in here. Those ones I'm going to go ahead and delete. I am not going to use those, but I just wanted to show you how or what it looks like when you generate one. And so now I just have these 2 keys right here. So the .pub is the public key. That is, think of it as our username, and the ID RSA is like our password. These keys work in tandem together to then connect to a host that will know about this publication key. And then once you do work with hosts, it'll be added to this file called known hosts. You may or may not have one of these things, but here is essentially what it'll look like, an IP address with a number of keys related to it as well. So that's pretty much it as far as generating the key. And so now what we can do is we could absolutely copy this key and put it anywhere. So if I do cat and hit enter, you'll see the actual contents of this key. I mean, by all means, open it up with a text editor as well. These contents will just go ahead and copy and paste into our cloud provider, whichever cloud provider you end up using. Now, using an SSH key just makes it really easy to SSH into any IP address, actually calling SSH without additional authentication in some cases. But you can also do all of this without an actual SSH key on your cloud provider or in your virtual machine of any kind. But we do want to generate one because I really want to make it nice and easy for working with my virtual machines. So I'm going to be using Linode for my production application. So be sure to sign up and jump into the console. And then you're going to want to navigate to your user and then over into SSH keys and loading something like this. Now you may or may not have any keys on here. We're going to go ahead and add one now. So notice that it says SSH public key. So that should give us the information that we need as far as what we need from our SSH keys. And that is the public key right here. And we can copy this with cat and tilde/.ssh right there. That will give us that value. I can copy this and paste in here. Now, some of you might have seen the shortcut with the pipe and pb copy and then hitting enter. That also does copy it as well. However, that does not necessarily work on a Windows machine. But anyways, with this SSH key, I'm going to go ahead and give it a label, and I'll call this AI as an API SSH key. Now, the only reason I'm labeling it that way is like if I want to delete it later. Now, as a user on most of these services, especially on Linode, you can add a bunch of SSH keys for your various machines. So the other part of creating an SSH key is perhaps you use a virtual machine to manage your virtual machines. That is completely okay and actually often encouraged to do so that your local machine isn't a point of compromise potentially. But anyways, we're going to go ahead and use our own local SSH key, and now it's in Linode. So the next part is actually provisioning our first virtual machine. Now we're going to go ahead and provision our virtual machine on Linode. So jump into the console if you're not already there and navigate over to Linodes and hit Create Linode. I'm going to be using Debian 10 as my base Linux image, but you can use any sort of Linux operating system that you find interesting. I'll just say that if you use Debian 10, at the very least, you will be configuring it the exact same way as me, but I think a lot of the configuration should work on a lot of Linux distributions. Next, the region we want is the one that's closest to you right now, especially while we're learning. Closest to you right now is great. When you go into further production, when you're not learning anymore, make it as close as possible to your end users, which often will be as close to you as possible. Anyways, so I'm going to pick Dallas because I'm in Texas, so I'm going to go ahead and use that. Next, I'm going to go ahead and select a shared CPU. This is the cheapest version that I can get, which is about $5 a month, and it's roughly a penny an hour. So that means that while you're learning, doing one that's a penny an hour is great. Or in my case, I'm actually going to do the 8 GB one, which is 6 cents an hour. Now, I will show you how to shut it down and all of that so you're not charged constantly. And we'll do that in just a moment anyway. Next, our Linode label, I'm going to call this AI as an API. Now, I might actually call this V1 just so I can distinguish it from future ones. You can always add tags in as well. The root password itself, I'm going to go ahead and let Google suggest one to me, and I'll copy this and paste it somewhere in my environment variables. Okay, so in this root environment variables, I'll just create one that's called root vmpw just to make sure I have it and also to show you another way to get in here. So the next thing is actually adding in our SSH keys are right there. I'm going to go ahead and add those ones in, and we'll go ahead and hit Create Linode. Now, do note that it is $40 a month, but this means that that's what it would be if you ran it 24/7, 365. It would be $40 a month for the entire year. Now, of course, at any time, literally any time, you can come in here and just delete it. And it will only bill you per hour that it was running, not per month, right? So if I delete it right now, I might get billed 5 cents, 6 cents, not very much. But obviously, hit up the support team if there's some issue with the billing. But do be aware that there are Linodes on here, dedicated Linodes, that you can run for like $4 grand a month, right? That's a lot. And then if you go to CPU level, it's for sure $4 grand a month, right? And maybe even high memory. No, that one doesn't. But dedicated CPUs are quite expensive. But that is, look at that machine. That is quite beefy as a machine anyway. So I don't imagine you're going to be running this very often anyway. So that's why we start with the lowest tiered ones of, 6 cents an hour. Now, the reason I'm not doing the 1 GB one is because, well, TensorFlow. TensorFlow is a pretty beefy package itself, so it can't just run on any machine. That's why I also mentioned if you did a Raspberry Pi, you would need at least 4 gigs, if not 8. So keep that in mind as far as our memory is concerned. But there we go. There is our now provisioned Linode. Now, I want to show you something that you might do down the line. I'm not going to do this again, but it's as simple as creating an image. We come in here, we create an image, we select a Linode, we add the disk to it, and then we add a label. So let's go ahead and call this my AI as an API v1, and let's go ahead and say standard config for my image. Okay. So it's estimated about $16 a month to save this one, but I'm going to go ahead and create it. And what this does is it creates a snapshot of my current project. In other words, once that image is done, I can go and create Linode, go to images, and I can actually work off of that image. I have a bunch of old ones as well, but once it's done, you could work off of that image itself instead of going off of the Debian image that we did earlier. And so that's a really key and easy way to stop your progress in its tracks. Sure, it's $16 a month to keep it on Linode, but you can then pick up whenever you need. And that's actually what I recommend, because turning this off doesn't necessarily stop your billing. In fact, I believe it does not stop your billing at all. So you would have to actually delete it. And realistically, do not be afraid to delete these virtual machines. The real production servers, when the services that use a lot of virtual machines, they turn these things on and off constantly. And I think Linode makes it pretty easy to do that as well. I should say on and off and delete constantly. So a part of what we're trying to do in this part of the series is to set up a system in which that we can, well, turn these things on and off when we want and just run a few commands and it will be back to where it should be, which means like, downloading all of our models, downloading our code, and turning it into a proper application. So yeah, that's it. Now what we want to do is actually SSH into this virtual machine once it finishes capturing that image. Now let's go ahead and SSH into our virtual machine. Now in my case, it is running, so it is ready for me to actually SSH into it. And I'm just going to copy this access right here. And then we'll go ahead and open up VS Code and SSH in. I'll hit enter. So every time you SSH for the first time into a new IP address, it's going to ask you this question. It's basically saying, hey, are you sure you want to go in here? Yes, no, or fingerprint. I'll go ahead and say yes. And notice it says it add to it my list of known hosts. Now, before I go any further, let's see what that list is. I just want to know about these things because you will run into issues every once in a while. So let's go ahead and list out the ./SSH. We see this file here called known hosts. So I can do cat SSH, and there it is, right? So that's the IP address itself. By all means, whenever you feel like it, delete that known host thing. It's okay because it's just going to ask you that question all over again. So to prove it, let's go ahead and do that. And I'll SSH again into that same machine by pressing up several times, say yes, and what do you know, there we go. So I'm in my virtual machine. But what I've noticed is I just logged in. I didn't have to do anything. Now this, of course, is how we provisioned it. We provisioned it with our SSH keys. But I also made one called delete me specifically to show you what you need to do when you don't add your SSH key or if you're on another machine. So I hit exit and I do SSH, say yes again. Now it asks for the password, the root user's password. That's this password right here that we set when we provisioned it. And there we go. So now I'm in 2 places at once, and I can just go ahead and shut this thing down, or rather sudo shut down. Plus, it will shut down in just a moment. I think it's sudo shut down now. There we go. And so it kicks me out of that session, but I also want to delete this Linode, right? I purposely made this virtual machine to just show an illustrated sample, and boom, there we go. That's kind of the habits you want to get into. I'll tell you, when I was first learning virtual machines and using them, I would be so hesitant to delete it. I'm like, I don't want to lose my work. I don't want to lose all the things that I did. But if you set things up correctly, your work will not be lost if your virtual machine goes away. In fact, you should never really lose your work if a virtual machine or any machine dies. A big part of it is because of Git and version control. Version control is a big part for us. The other part is object storage, which is what we set up in part 1. So anyways, now what we need to do is actually get the version control system working on our virtual machine and take a look at that. Now we're going to go ahead and install Git, both on our local machine as well as our production machine. So the local machine, I'm sort of assuming that you already have Git installed, so you can actually type out Git here. If you don't, definitely download and install that. Then in our production machine, we'll go ahead and install it here. So it's actually really simple. I'm going to break this down and we'll do SSH root at our IP address there. And then we'll do sudo apt update and then sudo apt install git with a flag, or we'll leave the flag out for a moment. But this will do 2 things at once. It'll update and then it'll run an installation. A lot of times it's going to ask you for yes or no. Are you wanting this to continue with the disk space that will be used? We say yes. Okay, of course, because we want Git installed. And if you have to run it again, just run it again, because every once in a while it might fail based on dependencies and all sorts of stuff. But anyways, I typically run it with the -y there, just so I don't have to answer yes every single time. Because usually if I'm hard coding this, yes, I do want to install it. Now, to me, the apt update and apt install is very reminiscent of pip with Python, but notice that pip is not in here, right? So my machine, my production machine, it doesn't necessarily have pip, and it doesn't necessarily have Python either. But in this case, it does have Python 3, so I can do pip that way. But again, it's also saying no pip is found. So of course, this is where installations come in. So we do Python 3-pip, something like that. And that's where knowing a little bit more about how a Linode distribution ends up working is good for us. So notice that pip takes up quite a bit of space, but it's actually not just pip. It's all sorts of other things that are coming in with it. So those are definitely packages you may or may not want to have. So now that we have Git installed and we have pip installed, well, I'll let this finish. It's time to actually use our code, right? So this whole time I actually stored our API reference code. The AI is an API reference code right here on GitHub, and you can absolutely use this code, or you can use the code that you have been working with. So in the next part, I'm actually going to clone this code. I'm going to move it into my own personal project, right? So my own personal username, not the Coding for Entrepreneurs one, but I'm kind of pretending like I'm you for a moment. And then we're going to work off of that code. The reason being is I want to make sure that the code I'm working off of is the code that I can actually change, and also code that's not already being used in production, right? So this AI is an API project, has a bunch of code in here and a bunch of things in here that we haven't even talked about yet and maybe never will, because I'm going to personally continue this one, keep upgrading it for the Coding for Entrepreneurs service. So it is an actual production application, so it will diverge a little bit from what the course code ends up looking like. So in the next one, that's what we'll actually set up. All right, so now what we're going to do is start the process of actually deploying our code into production, which means that we're going to have to clone a project and bring it onto our application. And so I'm going to be cloning this public project. I'm actually going to be using this public project going forward, and you absolutely can too. In the next section, I will show you how to clone a private repository so you can use that as well. So you have either option, because having a private repository is also something that you might be really wanting to do. So don't fork this code, just clone it, just grab the link itself. It will be in the description, but you can always go to the Coding for Entrepreneurs repo, the main profile page there, and finding this repository too. And so let's go ahead and SSH into our local host, or our remote host rather, and like that. And so what I want to use is git clone that URL, right, the entire thing, and then the folder I want to store it in. In this case, I'm just calling it proj. And so if I list things out, I see proj here. If you actually don't put the folder there, it's just going to use the name of the repo as the folder, just like that. Okay. And so I'll go ahead and delete that one. I do not need it. Okay. So if I cd into proj, hey, what do you know? I've got my project here. Now, of course, if you were following along with me this whole time, you'll remember I did python 3-m venv period, creating the virtual environment. Okay. So right off the gate, so right out of the gates, we have a installation error, right? Because Linux requires you to install virtual environments. Now that's fine. I totally understand that it needs that. But the thing is, are you always going to remember this? Now, my intuition is no. You know why? Because I don't always remember this, and I do this all the time, right? So I don't expect you to remember every single command you would need to actually build your environment, which is why we are going to be using Docker. So Docker is actually going to what we'll use to run our environment, but we could still go through the process of installing everything because it will give us some of the steps necessary to make that installation, right? And so we could keep going, create a virtual environment. Now, notice that it's Python 3.7. I was using Python 3.9, so it's already the wrong version of Python. So if I do bin activate and then pip install -r requirements.txt, you know, all of these things hopefully will end up working. Now, depending on when you're watching this, there's a really good chance you'll see a Dockerfile in here. That's something I will definitely do with you on the video, but it's going to take a little bit of time to install everything. And this is where it would almost certainly fail if you didn't have a big enough machine, is through the pip installations. Maybe with pandas, maybe with Jupyter, but almost certainly with TensorFlow. It'll just time out. It'll run out of memory altogether. So again, this is not the method I'll necessarily use long term, but it is a method I can use. It's just Docker makes things a lot easier, as we'll see, just to remember how everything needs to be installed and how everything needs to run. So let's go ahead and look at the private cloning first, and then we'll get back into the Docker related stuff. I'm not even going to let this pip stuff finish because, well, we're not going to use it. Okay, so let's go ahead and exit out of here, and let's get that private repo going. Now let's take a look at cloning a private repository. So the first question is, how do I even make a public repository private? Well, it's actually pretty simple on GitHub. So I'm going to go ahead and copy this link again, and I'm going to log into a different user. So in my case, I'm logged in as Team CFE, not Coding for Entrepreneurs, right? So I want to just go to my profile here just to make sure I'm definitely not Coding for Entrepreneurs, okay? And so now what I'm going to do is click this plus sign here and go to Import Repository, paste that repository in, and import it in as my private AI API or something like that. And now just select private, okay? So this is certainly not an option when you fork it, right? This, of course, is not a fork. So when changes happen to this repository, you won't know about them. That's how forks work. Forks, you will have the opportunity to know about them. Anyway, so I'm going to go ahead and begin this import. It's going to bring all of this code over, and that's going to be great. But of course, it is a private repository. So right now I have, well, if I go into my virtual machine here, this right now, this Git version is not like actually associated with any GitHub account. I certainly could associate it with a GitHub account, but do I want to? Well, yes and no, right? In my case, I'm going to say no because of how I want to actually manage any given virtual machine. I want to think of virtual machines as things as disposable as possible. I don't think of them like my local computer, right? I think of them as like a session with your phone. Like I have Chrome open right now. This is a session of Chrome. If I close down that session, it's gone. Once I start it back up, new session. I think of it more in terms of that, not in terms of actual hardware that I'm quote unquote destroying, right? Again, going back to like, let's not be afraid of deleting anything. Anyway, so now I've got this private repo. I'm going to go ahead and copy it and open up an incognito window. I should get this 404 page, right? So that will show me that it is private. And of course, if I try to clone it now, we can see what happens, right? So inside of our remote or our actual virtual machine, I'll go ahead and do git clone of that new repository and hit enter. It's going to ask for my username, right? Which is another way of saying, hey, we sort of failed here. Now, you can absolutely authenticate. You can do all those things. That's fine. But I want to do a little bit more of a sustainable method here. So let's hop back into our GitHub account, right? And so I'm going to go into settings, my user settings, scroll down to developer settings, click on personal access tokens, and we're going to go ahead and generate a new token. I'm going to leave an expiration of 30 days, and we'll just call this AI API access token, just to reference what it is. I can limit the scope for this, which is definitely a good idea. I'm going to go ahead and just grab the repo. What I will not allow it to do is to delete packages or delete a repo. Okay, so that's probably a good idea. Just don't let anyone delete something. We're going to go ahead and generate this token. I'm going to copy this token. And now I'm going to go ahead and jump into my virtual machine again. And I'm going to go ahead and say export token equals to that token. Now, the reason I do that is so I can actually reference that token later, just like that, right? So it's exactly the same token, which means then I can actually do git clone, okay? And going back to our repo again. So my repositories, my private IP. Okay, so here's our repository. Again, that's not going to work. So what we want to do is git clone, and just part of this right here we'll use. So first it's https:// and then the token itself, we can put it in here with some substitution that is done in Linux. So that's $, curly brackets, the token variable, which was this right here, right? So that name, and then colon. And this is x-oauth-basic at, now it's going to be all of this stuff right here. And I'll call this private proj, and there it goes. So cloned in private proj. Okay, so if I do git or git pull, right, already up to date. And so let's go ahead and just do an arbitrary file in here. So testing. And my new file, exclamation mark, commit new file. Okay, so I've got testing, my new file in there. And again, git pull, now it pulls that file down. Okay, so this is now a private repository that we were able to clone. Now, every once in a while, you might have to reuse that token. You might have to reclone. You probably shouldn't have to. It should actually use that token going forward, because if we look at git remote, -v, we actually see that it includes that token in there now, right? So if the token does go out, you just have to change these remote URLs to include that new token, right? You don't have to reclone it. You just have to update the token itself and set those URLs. That's not something I'm going to cover at this time because we don't really want to cover the private repo of this all. I want to make sure that our public one's working. So if you ever want to use the private one, you can. Okay, cool. Now I'm going to go ahead and install Docker on our virtual machine at least. You absolutely can install it on your local machine, and I recommend you do if you can. Not everybody can, but at the very least, we can definitely do it on our virtual machine if you set up a Linux machine. And so the idea here is actually pretty simple, and it boils down to something like this. So on my virtual machine, I have a virtual environment activated for Python. So if I type out Python-V and hit enter, I see that it says Python 3.7. Hey, it's Python 3, great. So far, so good. If I go on my local environment, my local machine with that virtual environment activated and type out Python-V, I get Python 3.9. Oh no. Now, there are so many applications that can probably run just fine on both of these things. But when we're dealing with something like machine learning, and specifically with TensorFlow or PyTorch, you might not actually have these environments working correctly just because of that Python version. And that's only one simple thing. So the question is, of course, on a virtual machine, oh, well, why don't we just install a new version of Python? Well, that would work, but the other thing is, what if you did want to test multiple versions of Python? In fact, what if you wanted to test several other kinds of applications, and also maybe you don't want to use Ubuntu anymore, you want to use Debian or vice versa? There's a lot of reasons as to why we would use Docker. I could totally go into those and talk about them all day, but the idea here is this simple. We want to make sure our environments are identical. Now, I did mention a long time ago that virtual environments help separate our Python packages from other Python applications, but it doesn't solve this problem. Both of these, if you didn't actually look at the Python version, you would assume that, oh, we're good. We've got virtual environments in both places. That's not what we want. Okay, so let's go ahead and close out our local one and just be in our main project here on the virtual machine itself, and I'll just go into the root of it. So first and foremost, we're going to be installing a Docker package or a new Linux package. So we'll do sudo apt-get update-y, hit enter. And then what we need to use is the https://git.docker.com command. And so what we're going to be doing here is curl-fs capital S L, capital L, that is, and https://git.docker.com. And then we're going to put it out or put the file to another file called git.docker.sh. And what we'll see here is this git.docker.sh. And we can actually look at this. So this is just a shell command that does all kinds of stuff to make sure that we can get Docker installed, right? It verifies what machine you're on, what distro you're on, and it does all of the things that you need to get Docker working on your Linux machine. So I'm going to just run the sudo sh or bash, either one, but basically running the script itself. So sudo sh git-docker.sh, and this will take some time to actually install Docker for us. Now, in my case, I do have Docker on my local machine, right? So if I type out Docker here, I will see that it is running. And if you're on a Linux and a Mac, you can absolutely get Docker, no problem. Windows users, you might need to have a professional version of Windows to actually have Docker work. So you have to have virtualization essentially. But the other thing about all of this is something to note is you can have a virtual machine controlling another virtual machine. So in other words, you could be using a virtual machine right now that's controlling your production application at some point with, again, SSH, just like we did getting in here. So that's another thing to consider as well if you were to want to use a local environment with Linux. In any case, I now have Docker in here. So if I do Docker PS, I see this, right? Or just simply Docker, I'll see that, okay? So the final command that I want to run, usually I'll do this after I install things, is sudo apt auto remove -y and hit enter, okay? And so I want to highlight why we use Docker. One more reason. We'll do that in the next section. But overall, Docker itself is highly, highly recommended to help isolate our applications, no matter what application it is, whatever programming language it is. It could be Python, it could be Ruby, it could be Node.js, it could be anything pretty much that's open source. And it isolates it very nicely, and then we can move it around a lot more too. So let's go ahead and see an example of it being moved around. So hopefully at this point, you're already convinced that Docker is probably a good choice for production, but I want to show you an actual working example with Nginx. So Nginx itself, if I try to run systemctl status Nginx, I get Nginx service not found, right? So I actually have not installed Nginx at all on my local virtual machine, right? So what I want to do now is just say Docker run, and I'm going to expose the port of 80 to mapping to the port of 80. I'll explain that in a second, and I'll just run Nginx. Okay, so right off the bat, it says it can't find Nginx, so then it starts downloading it. It literally starts doing everything it needs to do to run Nginx. Okay, it actually happened pretty fast for me. And so I go back into, my IP address here. I open it up in a new window and welcome to Nginx. So it's now running in seconds, right? So if I hit cancel, it stops it from running with Control C. Now it's not running. I do that again, right? It's going back, it's running, okay? And so what I can also do with Docker is I can say, instead of just run, I can also add a restart policy. So restart and put it to always, okay? So that means that this application will always restart, assuming it's in detach mode. So the -D will put it into detach mode. So there's the whole command. I hit enter now, and now I can't just close it out. I can't just run Control-C to cancel that from running. But if I look at the IP address itself, it's still running, okay? So what's happening here is Docker is running this in the background. That's what that detach mode is. So if I do Docker PS, I can stop it with Docker stop that. Now, we will absolutely use these commands again, so don't worry about trying to copy them or remember them or anything like that. But what it will do here is it's going to stop Nginx from running in the background. But what I want is actually to have it always running, right? So now it's stopped, but I definitely want it to always run. When I say always run, I mean, going back into our Linode console here, reboot, hit reboot, our system should go down, Nginx should go down. I should get kicked when it actually does reboot, so it's starting to reboot. And that is, of course, a common problem for applications is, you know, if the system goes down, then it's no longer accessible. But what's important too is that when the system comes back up, right, so it's rebooting right now, when it comes back up, is it's still running everything that it should be running, right? So there's many ways to make sure that it is running what it should be running, but what I just showed you with Docker is one that should work, or at least let's go ahead and test it so we can make sure. Okay, so it finished booting, and let's go ahead and take a look. I'm gonna refresh in here. Now, of course, when it does reboot, it's not necessarily gonna come online right away, but I will give it a moment. While that one works, I'll go ahead and try to SSH in there as well. I'll run Docker PS to see, hey, what do you know? The container is going up. It's been up about 7 seconds. And if we refresh in here now, it's back on, right? And so we could also test this if it shuts down and see if it comes back on when we shut it down. So power off, okay? And so right away already, if I turn this into an image, then we would probably have Docker running already. Like in other words, Docker would boot up already, okay? So I'm gonna let you guys finish shutting down and bringing it back up to verify that. But that's just a really simple example, a very practical example of when you might use Nginx and Docker, right? But also it shows you Docker itself. It's showing you the power of just using Docker on its own. Now, we totally can combine Nginx with our web application. That's not something I'm going to do in this one. It's not really that hard to do, but it just adds complexity to maybe an already complex system. But what we want to do is actually get our own application running here. So we need to create what's called a Dockerfile to do that. All right, so now back into our local project, we're going to go ahead and create our Dockerfile. Now, the Dockerfile is just a file, a single file that will have a bunch of steps in it that Docker needs to take to configure the Docker environment correctly. That's it. It's not a whole lot different than what we've been doing manually with our virtual machine. Let's take a look at what I mean by that. So first off, the very top of it, we use some sort of base image, right? So I'll explain that in a moment. Then we'll probably copy some files. We might change our working directory. Then we might run some commands. And then we also might want to have one final command that will actually run our web app. Okay. So at the baseline level, this is our Dockerfile. And if we think about it, we've been doing this on our virtual machine too. So the base image, what does that mean? Well, going back into Linode, we went to create, we picked an image, a Linux image. This isn't actually much different, except I can actually declare something like Python 3.9 or 3.8. I can actually get that image, which means that Docker, the company that runs the open source, container system, actually made one for Python. But there's one for Debian, there's one for Ubuntu, there's one for all sorts of different languages here. So I'm going to just use the one from Python for now, just for a second. Then we want to copy whatever files we have available. So that's these files. Now, I would say you should be very explicit to the things that you want, right? So the files that I want, for example, I want to bring in app, and I'm actually going to leave it into app/app, or let's go ahead and call it proj/app for a moment, okay? So this is going to take the app folder, this one right here, and copy it here, right? So again, we're treating this Docker file very similar to what we treated our virtual machine like, right? So I copied over, or I cloned code from GitHub, and I saved it somewhere, in my case on the virtual machine. I saved it into root/app like that. Or rather, I think I called it root project app. And then the other one was private, proj like that, right? So I'm doing something very, very similar, but it's just with the code that's local. It's not with the GitHub code itself. And so that's where I put it in like this. Okay, so now the working directory I want is really just app. So what that means is this command right here can actually run, something like Python mp pip install and requirements.txt, or can it? Now, the app folder is being copied, but is anything else in the app folder being copied? Well, requirements.txt is way down here. So that'd be another thing I would need to copy. So copy in our local file folder, copy requirements.txt into the app requirements.txt, right? And so now this command can work, okay? So we can keep down this path of all of the things I need to install. Now for you guys, I actually already created a base image that's going to be easy to use. So first and foremost, if you go to the GitHub repo, you can look for docker-python and look for Python 3.9/web app. And in here, I have a bunch of base images that are going to be easy to just implement. So in our case, I'm going to go ahead and go into just Cassandra itself. Okay. And then the Dockerfile here, here's that base image, right? So you can absolutely copy these things. Notice that it's running apt-get update, apt-get install, installing all sorts of things. It's installing the Cassandra driver, right? So we can do all of those things, or I can actually go from Docker Hub itself and use some of the base images that are in here, like 3.9 web app Cassandra. That's the one I'm going to use. And so to use this, I'm going to go ahead and copy this docker pull command here, come back into my Docker file and do from pasting that in. Of course, docker pull is related to a Docker command. I want the image itself, and there it is, right? So there's all kinds of images on Docker Hub. This is just one I made specifically for this project. So it's going to be really, really easy to just run it, and we don't have to remember all of the commands. Again, if you want to know what all of the commands are, you just go back into the Docker file for it, which is this one right here, 3.9 web app Cassandra, Python 3.9 web app Cassandra, right? There's a reason for that, organization there. Anyway, so here's the Docker file. So this is it. So if I wanted to use that directly, I could just copy this and paste that in there like that, right? But this shortcuts it. This makes it a little bit easier on me for my applications in general. So now that I've got that, I've got my app in here. The next thing, of course, I actually want to run the installation for sure, but I'm going to do it just slightly different here. I'm going to do Python 3, and this time I'm going to create a VENV, or a virtual environment at opt/VENV. That's actually a very common place to create a virtual environment in production. This is where the root of that virtual environment will be, not necessarily where my project is. In fact, my project is going to be an app, right? And so we'll take a look at this in a moment, but then I'll just go ahead and run opt/venv/bin/python-m pip install-r requirements.txt. Okay. And then this next run command, I'm going to go ahead and leave that out for a moment. Okay. So the final thing is I actually need to run a command for our project itself. Okay. But I'm not going to do that yet. I'll actually come back to this Docker file. I just want to get some of the baseline stuff working before I go any further. So for now, I'll go ahead and do git status, git add, git commit, and there's going to be 33 add Dockerfile. And then we'll go ahead and merge it to our main. So git checkout main, git merge, and 33 end, and then git push 33 end. Now, of course, if you don't know how to do all these things, we could git push origin 33 end, and git push origin main. Just a way to use my branches so our lessons are the same all throughout. So anyways, now that we've got that, let's go ahead and look back at our original code, right? So API is an AI course. If we scroll down a little bit, I now have my Docker file from 33 seconds ago, and there it is, okay? So it's an incomplete Docker file for running our Python application, but it should at least do something for us, right? In other words, now going back into my virtual machine, let's go back into Linode, grab our IP address here, and SSH root at, Okay, so we're going to list in or cd into proj, and we'll get pull origin main. This should pull that Docker file, and sure enough, there it is. Okay, and so I want to show you how to actually use this Docker file. So we will build it in just a moment, but the idea here is we have the Docker file, it's in there, it's ready to go overall. But all of these commands I can run right now, or I could at least run this one so you can see that it does work at least on my virtual machine, right? So let's go ahead and do that. I'm going to copy this command right here. I'm in the root of my project, right? So that's important as well. I'm in the root of my project, and it has actual requirements.txt. And notice that it's running, right? So it's absolutely installing that command. So whenever you're in doubt and you have some issues with your Docker file itself, hop into a Linux virtual machine and run each command in here. Now, in my case, I already had this code in here. That's why I was able to test at least this command. But that would be one way on how you could test it just directly from the Docker file itself. And that alone, too, could potentially just be your reference file for getting your application running. It doesn't necessarily mean that you're going to use Docker either, right? So it could just be an ongoing reference, and yet another reason to just kind of dive a little bit more into Docker. But in the next one, we're actually going to build the image itself, and then we'll add on to it as much as possible too. All right, so now we're going to go ahead and build our Docker project. It goes Docker build, then we tag it AI-API. That's what I'll call it. You definitely need to tag it, so that -t is for that. And then we'll do -f, Dockerfile, and then period. So before we actually run that, I want to just mention what's happening here. First off, we're calling the build command, and we're tagging it this way. Second, the Dockerfile itself is this Dockerfile, right? So it's just referencing this Dockerfile. If you had a different name for the Dockerfile, you would just reference whatever that is. And then period means, hey, build everything in this location, which of course that Dockerfile has some copy commands in here, which we'll look at in a moment. But anyway, so let's go ahead and run this with, again, Docker build, the tag, the Dockerfile itself, and then period, and it'll go ahead and run. So first and foremost, it's going to actually extract this base image, all of the things that build up this base image, which are all available from Docker Hub. This is where it's stored. So it goes username, Docker Hub repository, and then the tag itself, right? And that's true for any image that's on Docker. So even if it was Python, it'd be the official Python repository. In this case, it's the Coding for Entrepreneurs Python repository with the tag that I associated to it. And so it's going to take some time to actually build this thing out. But the first time we build it, it will take a little bit longer than future times that we build it, depending on all of the commands that we may or may not add to this. So it's certainly possible that in the future, it will have more commands. It will take a little bit longer to end up building this. But what we'll see here is it will go off of our requirements. It's copying those. It's creating a work directory. It's creating our virtual environment. And then it's going to run all of the necessary installations on this container image itself. And so that's what our build command is doing. It's building a container image, right? So it's a container image that we can run at any time. Like we saw before with Nginx, all it did was download a bunch of stuff like this did, but then it just ran it, right? So if I were to build it and save it somewhere else, as in not build it on my virtual environment here, or my virtual machine rather, then I could totally access that one, right? So in other words, if I made this entire project on Docker Hub, I could do that, and then that would be the project I would be able to pull and run. But I want custom code, I want to change things, and I want it to be specific to my needs right here, not just a general package itself, right? So this will take some time to actually download and install, which is another reason why we actually have the Docker version going that we have, but also the reason that we add that bigger machine itself. Because if you see TensorFlow right here, it is, well, it's pretty big. It's a pretty big package. So it's going to take some time for it to download. And that would have been very true if you tried to just download it in your virtual machine as well. So I'll just let that finish. But the idea is every time we make a change now, I can still run the Docker build. Notice I am local, but I'm just going to explain some things here. So Docker build, I can still do, AI-API and something like that. And this will build a new version. But what I can also do is just tag it So if I did -v1 and then the next one, v2, v3, and so on, I could continuously do this. That way I have a bunch of different versions of this project able to be ran. And so that's a potential that you might do in the future at some point as well. Now, we are certainly not done with our Dockerfile, so I do have things that I need to update for it before I even go much further with this. But what I want to see is, once it's finished building, I actually want to see the actual file system that's in there and the different commands I can run. So I'm going to go ahead and let it finish building, and then we will take a look at those things. All right, so it finished building, and what you notice is it says it built and tagged latest. So if you don't add a tag, it's just going to consider it to be the latest tag, and that's it. So now what I can do is run that. So the way I'm going to run it in this case is just going off of the tag itself, whichever tag I want to use. And I just want to see the file system. So it's docker run-it and then ai-api and then bin/bash. So in the future, we won't necessarily have to run all of this stuff, but we definitely will still need the tag. Bin/bash is essentially like saying, let's SSH into this Docker. It's not the same, but it's going into the Docker app itself. So notice that it did change a little bit. So if I list things out in here, I've got my app and requirements.txt. So quite literally the things that we told it to bring in. This, of course, is different than what's on the virtual machine itself. So now if I were to want to run any of my virtual environment commands, the virtual environment, if you remember, is in cd/otp venv. So I can, of course, activate it like this and then do python-v. And now I've got the correct version of Python, at least 3.9. You know, that last version, of course, matters as well, but the 3.9 is the key thing here. And so going back into the root of this user, what I should see here, or rather into /app, not the root of the user, go where I actually copied all of my stuff to. Then I can actually see all the app itself, and I can cd into the app also. And in here, actually, let's go back a little bit. I should be able to do uv-acorn, right? And I can. And so uv-acorn, and then the app, and it was app.main:app-reload. And this should, in theory, run our app. Now, I have environment variable problems, so that's something I need to address, of course, but it is able to essentially run the app. So the environment variable stuff is going to come in with our Dockerfile once we actually get that all up and going correctly. But overall, we now have a Dockerfile running, or potentially running, on our virtual machine. Now, when I say potentially, I mean the actual app itself is not running, but the Docker application, the Docker container, is running on that virtual machine, and we can exit out of it just like that. Okay, so now we actually need to add in our environment variables. So this is actually going to be a fairly straightforward process, but it's something that we should really consider how we're going to do it. Now we're going to go ahead and handle our environment variables. So there's two features to this. One, our actual virtual machine needs it, and two, our Dockerfile also needs it. So if we do copy.env to app and then .env, that's exactly what we want to do. In fact, we don't need the dot in front of that app there for any of these. Okay, so we certainly need that in order to run our application. So I definitely need to add these environment variables, but before I do, I also want to add another script file in here, and I'm going to call this entrypoint.sh. Okay, so the reason I'm doing this is so I can actually run my application itself, right? So inside of the entry point, what I'm going to do is I'm going to declare it as the bin/bash, right? So this is a bash script that's going to be running, and it's going to be using OTP/venv/bin/gunicorn. And this OTP venv bin is much like our local virtual environment bin, except it's going based off of the Dockerfile itself, which is creating the virtual environment in OTP venv. So that's where that's coming from as well. And so the gunicorn app itself, we want to add a worker tempter, and those will be dev SHM. That's a very common thing to do. And then we actually want to add in the worker itself, the worker process, the worker class that is. It's going to be a uv-acorn class, and it's workers.uv-acorn worker. And then we're going to go ahead and bind it to the 000 or 0.0.0, and then a port that we want to use. So I can use just a standard port that comes in, or I can have a default. So I'm going to go ahead and do run port equals to the environment variable of port, or I'm going to set it equal to being 8000, and then we'll just do something like that. Okay, so there's another command now for Dockerfile. Two things, the environment variables, and then this Entrypoint command, so entrypoint.sh. That, of course, I need to also copy. So we'll go ahead and do copy dot, or capital copy dot slash entrypoint.sh to app slash entrypoint.sh. Okay, so a couple things that we definitely need in production in order for this to run. Now, the other thing about this, when it comes to copying, you might be tempted to just do copy dot slash app like that. This would copy everything in your current working directory. So it's literally everything in here. I think it's better to go one by one on the things that you for sure need. See, I copied this entire app folder because I know that I'll probably need it in production. So just a little thoughts on that one. Okay, so now we have a new Dockerfile. So I'm going to go ahead and update it. And I'll just do git add -- all, git commit. And this is going to be the, add environment variables, basically. Add environment variables. And then we'll do git checkout main, and then git merge. Looks like I'm using the wrong branch, but that's okay. We'll do 34 end and git push origin main. Okay, so now, of course, looking in our GitHub repo, we should see that. So we should get our Dockerfile in here. Notice the .env is still not showing up, and our entry point is in here as well. Great. So both of those things are working. I did realize that we also need to update our requirements because the entry point itself is using GUnicorn. I don't think I ever added that into requirements. Oh, looks like I did. Okay, good. Just wanted to verify that that was there because it definitely needs it. Okay, so now the thought process is, well, we need to update our env file in our production application. So let's go ahead and navigate in there. And let me just grab the IP address. So SSH root at, okay, so into cd proj, we need to make our environment variable file in here. So I'll go ahead and do sudo nano.env. And I'm literally going to copy my local env file here. I don't need the root password though, but I'll leave everything else out in here. Okay. So this actually would be a really good time to be like, okay, I'm going to change all of these environment variable files here. It would also be a good time to mention that in the long run, I would not actually hard code the env file here. Instead, I would use something called a CI/CD pipeline to configure all of my virtual machines, right? Now, there's a lot of complexity that goes into that, so I just want to make it really simple by just copying and pasting our environment variables here right now. Okay, so at this point, I should be able to run my Dockerfile build again. So docker build -t AI-API tag, I'm going to call this version 2, and then -f Dockerfile and period. Okay, so it built it really fast this time, but I didn't actually change anything. So I actually do need to do git pull origin. If I do git status in here, these things have modified a little bit. That's okay. I'm not going to worry about that for my production environment. But I do not see .env in there, even though if I do cat.env, it's definitely in there. Okay, cool. So again, I'll go ahead and build this new version. And now we see that it's going to take a little bit more time. It's not going to take nearly as much time as I did before, but it will still take some time. I did catch something that I should have done in my Dockerfile, and that is making this entry point executable. So we're going to have to do run, and this is chomod +x entrypoint.sh. It certainly still might work, but there's a good chance that it also might not. So we want to make sure that whenever we have scripts that we need to run, we make them executable. And I'll actually do this up a little bit more. And so the installation part of Docker will take the longest time probably. But now that I've added that entry point, I'll go ahead and add it and do git status, git add, and then git commit. And we'll go ahead and say updated entry point in Dockerfile, and then do git push origin main. Okay, so of course now our production app could actually update. So what I just showed you actually was the process that you're going to have to go through from here on out with your project, right? And that is you work on some code locally, you push it into your GitHub repo, and then on your virtual machine, whichever virtual machine you're running, you're going to have to run a few commands. You'll still have to do some manual work. There are tools that automate all this stuff completely. Like I said, CI/CD tools, one of them being the actual GitHub Actions itself can run this, right? So the production version of what we have does have actions to run this, to actually spin up a new infrastructure item, destroy it, update it. All of those things are all in there. And that's all done through doing something called Terraform. So Terraform's actually doing all of it. It's a really, really cool tool. Let me know if you want to learn more about it. I'm not going to be covering it in this series, but it is something that you might consider doing to help automate all of this configuration and also the deployment process. Because you see, like, it's not fun to sit here and wait for it to finish so I can do a few more commands. But once we have it mostly configured, it's not going to take that long. It's just something that has to be done on a regular basis after you actually run a deployment. Like you actually push some new changes into code, you'll just have to go to your production app and make some changes there. I'm going to let it finish real quick, and then we will actually go back into the Docker image bash shell to test out a few more commands in there too. Okay, so it looks like it worked fine. So what I want to do first is Docker and then the dash or Docker run -it, our most recent version here, and then bin/bash. Okay, so I'm in there. And so what I'm hoping that I'll be able to do is first off, activate the virtual environment. So source OTP venv activate, or rather bin activate. Okay, so if I do pip freeze here, I should see all of the pip freeze things. But now what I want to do is actually run one of my pipelines. I think I actually didn't bring them in, so that might not work. So let's go ahead and just use uviacorn. And it's app .main :app reload. And now I don't think we will see the same issue, except I don't have my Astra DB Connect in here. So that's a problem. I also don't have my models in here, or at least I shouldn't. Right? So if we go into the app, so cd app, nothing in here would show me my models, which in my local environment, oh, my models are not even in the app itself. Forgot about that. So cd back a little bit, right? And so I definitely need to implement the pipelines as well as getting our models installed and working correctly too. So that's something we'll do for the next few. Now I'm going to go ahead and bring in my pipelines folder for the Pypyr commands. Now I do intend to add more pipelines in here, which is why I'm bringing the entire folder, not just one of the files. So up in my copy command, I'm going to go ahead and do /pipelines and put it into app pipelines, just like that. Simple enough. Go ahead and run this, and it's going to be running off of our OTP venv bin. And this one, I'm going to use Python -m and Pypyr. So just to make sure that I'm using that virtual environment's Pypyr, not somehow using a different version of Pypyr. And then we want to call it inside of the pipelines themselves, and then the actual pipeline that I want to use, which is AI-model download. Okay, so notice that I'm actually downloading the model directly in the Docker container when it's being built. This is not necessarily the most effective or efficient place to put it, but I'm trying to do it for simplicity purposes in this deployment and not go too much into Docker. I think we already went a lot into Docker. There's definitely more ways to improve this is kind of the point. But this actually should work for us. And hopefully what it'll end up doing is creating and getting us the necessary pipeline download going. So let's go ahead and update this. So git status, git add, and then git commit, and 36 added Pypyr pipelines, and then git checkout main. Oops. git merge 36-end and git push main origin main. Okay, so we made a change, we committed it, we pushed it. Now going into our actual virtual machine, I copy the IP address there. So SSH root at, we cd into our proj, git pull. Okay, Dockerfile was updated. We can look at that Dockerfile. There it is, and there it is. Let's just make sure our pipelines are in here too, in the local repository in this remote server. They are. Okay, cool. And so now I'm going to go ahead and give this a shot. Now, one of the things I could have done locally is just tested that the pipelines are correct, like the actual somewhat relative path is correct, but I'll leave it just like that. This time I'm going to go ahead and do docker build, and I'll just leave the tag as AI-API just to keep it nice and simple, and then the file of Dockerfile and period. Okay, and so now I've got no entry point. That's odd. Let's see our Dockerfile itself. Ah, yes. Working directory was in the wrong location. Okay, so simple fix, but let's go ahead and update it. So git status, git end, git commit, updated working dir location, git push origin main. Okay, and then in our production, git pull origin main, or just git pull, and we'll run it again. Okay, so now it should work. Great, and we'll give it a minute. I really want to check to see the actual pipeline's working, but the good thing is it's definitely copying the pipeline in there. It does have to install all the requirements before running the pipeline. I think that makes a lot of sense to me. Hopefully it does to you as well. But basically we just need to run any given pipeline here after all those requirements are done. So let's go ahead and let the requirements finish, and then we'll see the pipeline. Okay, great. So it finished, and we should just check that the models are in there. And so we'll go ahead and do our docker run-it ai-api bin/bash. And I just want to verify. So I see the models folder in there now, and spam SMS. And there we go. So we've got all of the things related to this model. So it's definitely working. Another reason to use those pipelines is just really, really simple to just run this pipeline here. And so, of course, now the last and final piece to this is to make sure that we actually get the connection. So app ignored AstraDB connection, we need to get that into here as well. Now, one of the methods to do it would be actually using the pipeline, right? So to upload the connection into a object storage of some kind and then to download it. The thing I don't love about that is, well, it's not encrypted, right? So what I actually want to do is encrypt this, upload it into Git or wherever, and then decrypt it in our production application. So that's the sort of remaining step as far as building the application itself is concerned. And then we just need to run it and expose it to the world. Fairly simple, but it's something we'll do in just a little bit. Now we're going to go ahead and secure our AstraDB connection bundle. So if we actually look at this bundle and unzip it on our local machine, we should be able to unzip it and see that there's certificates, there's keys, there's a trust store, there's all sorts of good stuff going on in there that we want to secure. So delete the unzipped folder. Now I will say that this bundle is probably useless without these two keys right here in your environment variables, but why not encrypt it if we can? And doing it so is actually not that hard because of the cryptography package out there. This is an open source package for doing modern cryptography. Now, I am not a cryptography expert by any means. That's why I use this package. So I'm just going to be going off of the assumption that this package does add a layer of security using the encryption that we have here. Now, I would say, or at least offer, that doing some sort of encryption is better than no encryption. So that's what we're going to be doing now. Before we actually implement it into our project, though, I actually want to use Jupyter and notebooks to see how this is going to end up working. So go ahead and open up Jupyter Notebook if you don't already have it running. Go ahead in there, into your notebooks, and create a Python 3 file in here. And we'll call this encryption. Okay. So if you have to, just run pip install cryptography. You probably will. Now we definitely will need to add this into our requirements.txt too, so we might as well add that in there as well. Okay, and so I'll just run that. Oh, that's another way to run pip. You can use exclamation mark or the % sign. Doesn't really matter. Some people prefer this, is really the point there. Okay, so what we want to do here is we want to import the fernet to generate a key. Once we generate that key, we can start actually encrypting data. So let's go ahead and do this. So from cryptography.fernet, import the class fernet. Okay, so to create a key, it's simple. It's just fernet.generate key, hit enter. Notice that it's in bytes. It's a byte string. Now this is not great because what I want to do is actually put this key in my environment variables. So it's going to be a lot easier to sign things. So to change it into just a string, we can decode this byte key by using UTF-8. And there we go. So there's our new encryption key using UTF-8. So I'll just call this my key. All right. So how do I actually sign things? Well, to do this, we're going to go ahead and actually sign the thing we want to sign. So I'm going to import pathlib, and I'm going to go ahead and give my base dir, and that should be, well, basically just a couple back. So pathlib.path, and this should be my root project dir. Actually, that's not the way to do it. We want to do path and parent, and then we'll go ahead and do exists. Cool. And then we'll go ahead and do our app dir, base dir and app. And let's go ahead and make sure that that exists too. Okay, so it's not in the right place. Let's go ahead and get rid of the period there, do .resolve, and then parent. And there we go. Cool. So using pathlib inside of Jupyter is not always the easiest thing to do, but I certainly want to have this. Now what I want is my ignored dir, and that of course is inside of my app dir and ignored. Now the ignored really just means ignored on Git, not really something I want to ignore in the long run. So what I want to do is create a encrypted dir, or let's call it a secure dir. And this is going to be our app dir, and we'll call it encrypted, and then decrypted dir. And what do you know? Decrypted. Okay. So we've got our inputs. So here's our input. Secured will be an input at some point, and then decrypted as the final output. So how do we actually encrypt something is the first question we need to ask ourselves, right? So what we want to do first is loop through every path in our ignored directory, and we'll go ahead and give it a glob here to get all of the files that are in there. I'll go ahead and print out the path. There we go. And so I'm going to encrypt every file in here, and yes, including even dsstore. Now in gitignore files, this probably wouldn't show up in the future anyway. I could also be very explicit as to what file I want to encrypt. But the idea to me is I want to have an entire directory that I'm encrypting whatever's in there. I don't necessarily need to make a bunch of conditions of certain files that should not even be in there. dsstore is something that will pretty much only happen for Mac users. So if you're on Windows or Linux, you probably won't see that. So anyways, what I want to do is turn this, so this local path here, I want to actually encrypt it and then store it into my secure directory. So I'm going to go ahead and get a relative path for this, and that's going to be path.relative to the source directory, right? So that's this path, of course, relative to that. And now I can print out that relative path. Let's get rid of the original path. And so there we go. So the reason I'm having relative path is so that I can have other files in here as well. Now the glob would have to change to have other kinds of files, but really I just want whatever this relative path is, because that's what I'm going to store in my encrypted data. Okay. So the destination path then is going to be my secure directory with this relative path. So I'll call this the destination path. And we'll print that one out. Okay, so the input path is this one. the destination path is that one. Now, why am I doing that? Well, part of the reason is because we need to use this key. This key itself will then sign all of these things, or encrypt all those things, not sign them, but encrypt them. And so we're going to use that key with a fernet. So f equals, or fur equals to fernet with that key. Now, it's very often that you'll see this as an f variable. I don't like using the f variable simply because of f substitution, f string substitution. I think a lot of people get confused with that. Anyways, so fernet is fur. And with this, what I can do is I can open up my bytes, so the data from any given item here. So I'm going to go ahead and say, path bytes equals to the path dot read bytes. This, of course, is the same as open, a file path and read bytes. Just a path loop way of doing it. So since I have these bytes, I can actually encrypt it. So data equals to fernet dot encrypt of those bytes. Okay, so this is the new data that I want to store in my destination path. So it's simple, destination path dot write bytes of that encrypted data. Pretty simple. Okay, so let's go ahead and run that. And oops, I didn't initialize fur. Let's try that again. All right, so we've got no such file, encrypted data. Okay, so the actual secure directory is not there. So let's go ahead and create it. Secure dir make dir exist okay, being true, parents being true. We'll do that same thing for our decrypted dir once we get there. Okay, so let's run that again. Now it runs all of those files. So let's do this same idea here, but this time using the secure directory as our input. And we'll go ahead and print out the path. And what do you know? Those two files are there. Now, if in your case, it might be just one file, right? Just dstore might not be there again. Okay, so now if we go inside of our project here, if I open up my AzureDB Connect, I've got, well, different data. If I look at the zip file, it does this, right? So if I actually try to open this, opening up our Finder, let's go into that encrypted folder and try and unzip this, it's going to give me an error. It cannot be unzipped. That, of course, is because we just encrypted it. Okay, so to decrypt it, well, we are going to basically do this exact same thing, except not going to the secure directory as the absolute directory, but rather to the decrypted directory. Now, we could go back to the original directory, but I think that might cause a problem with your data. So let's not do that. And of course, this is going to be relative to this path. Okay, so now the path bytes, instead of using encrypt, we use decrypt. Then we have a relative path to our secure directory, right? Again, our destination path is going to be based off of those two things. Our destination path should be already there. And then there we go. So we go ahead and run that. And now it should have decrypted that data. So here's that bundle again. And if I open this up, what do you know? In the decrypted folder, and it's able to be decrypted. And of course, this is all thanks to this key right here. And yes, absolutely, we can use different folders, but we can also add a bunch of things to any given folder. So I can go ahead and go like this. Let's go ahead and add a few of these connect bundles. I'm going to delete all this stuff and just leave the one connect bundle in a little bit. But I just copied all those and now have a bunch in there. Okay. So yet again, I'll go ahead and secure all of those. So inside of encrypted, there they all are. And then we run it decrypted again, and there they all are, right? It's a pretty cool and simple way to do this for encryption. Now, of course, one of the biggest downsides is the fact that we are using this encryption key. So if you were to change the key and then try to decrypt some stuff, well, let's actually delete all of these things first. And now let's go ahead and try and delete some stuff. Oops, let me try that again with changing the key, running that, initializing fernet again, and deleting all of these things. Key changed, go into decrypt, run it again, we get a signature did not match, right? So this is where you might get into some issues. And that's why I have 3 different folders. So the ignored one is really the original, and then we've got encrypted and decrypted. So encrypted is the only thing I will check in to production. Decrypted is the only thing that will be finalized or used from our app. In other words, in our app itself, when we actually try to load that in, this right here, this cluster bundle, we'll have one more step in here looking for the decrypted version as well, right? Because we certainly want to have some of those things in there. Okay, but before we go, I want to go ahead and clean up this a little bit and delete those folders and delete our extra ignored connection bundles in here. Because now we want to take what we just did in a Jupyter notebook and actually turn it into some functionality, an actual Python module, so we can call these methods just really easily. All right, so now we're going to go ahead and convert our Jupyter notebook into an actual module that our project can use. So I will go to this encryption one and make a copy. And this time I'm going to call it encrypt and module. Without pi at the end, but just encrypt module. I already have cryptography installed, so I'm not going to do that one. And I'm just going to rearrange things a little bit so it's actually like the module itself. Now, what I probably won't need are the paths inside any given method to run this encryption. So let's go ahead and start our first one. And I'm going to define it as encrypt_dir. It's going to take in an input directory and have an output directory. No big surprise there. And so it's going to take all of these things in, right? So the fernet, the actual loop path here. And let's tab these in. Okay, so the input directory is what's going to be looped through. Now I want to make sure that I'm turning the input directory into a pathlib path. And that's also true with the output directory. So pathlib.path as well. And what we did see before when our directories weren't created, this loop had a problem. So we just need to create one of the directories here, or the output directory really. So output dir dot, make dir exists okay in parents. Okay, so there's our encrypt directory. Now the key itself though is actually not great, because what we want the key to be is based off of OS. So we want to actually put it into our environment variables. So what I'm going to do then is I'm going to define a method called generate key. And it's just going to really return this fernet here. Okay, so then I can run this basically one time. Let's insert the cell below. I'm not going to have to run this very often. Well, let's make sure everything has been triggered. There we go. So here is my encryption key now. Let's get rid of that. Jump into .env. And create encryption key and set that equal there, no spaces. Okay, so now this is what I'll use for my actual key, being os.environ.git. Okay, and we'll push that up a little bit. So this encryption key will be used in our function here, and I'll just say key is equal to that. And if not key, then we'll go ahead and raise an exception. Encryption key is not found. All right, well, let's give it a shot. So I'm going to go ahead and do encrypt_dir, and this is going to be our app_dir, or well, we can actually use these directories here. So I'll put it in as a string though, because it does not need to be a pathlib, because it gets converted to a pathlib. And then we want our decrypt or our encrypted dir, so our secure dir, string and secure dir. Let's run that function. And there we go. So I get ignored dir is not defined. Of course it's not. So these items, I need to update a few things in here as well. So relative to import dir. Okay. And then we want to make sure that our secure dir is in here as well. And we've got ignore dir. Oh, it's probably from here. Okay. And this is one of the things about copying a Jupyter notebook. You need to make sure they're all ran. Okay, there we go. So encryption key is not found. No surprise there, because we didn't actually load it in. So let's go ahead and import from .env, import load.env, and run load.env. Okay, and so again, I don't think we'll have it encrypted. It actually loaded. That's great. So load.env is a really cool thing. I thought I'd have to refresh the kernel, but I did not. Okay, so now let's go ahead and run it. Now it's using that encrypted dir method. So back into our app, hey, what do you know? It actually created decrypted too, but that has more to do with this cell right here. So what I'm going to do now is get rid of these, and I'll delete it again. So delete encrypted and delete decrypted. Okay, so we run it again, and sure enough, encrypted is there. Next one is essentially just copying this and turning it into decryptor. Everything's the same except for this right here, and this should be decrypt, right? So we might want to change this to being secured dir, right? And just changing the input directory to being that. But that's like something that's so minor that probably doesn't even matter. In fact, we would probably have methods, one single method with a mode of like encrypt or decrypt, but I'm going to leave that to you if that's something that you want to do, because the only thing that really changes is this decrypt part right here. That's it. Okay. So now I'm going to go ahead and get rid of this method here, or this loop. We're going to go ahead and call our decryptor just one time, just to make sure it's working. And of course it changes from the ignore dir to the secure dir, and the encrypted dir or decrypted dir as the destination. Okay. So we run those two things and jump back into our project. There's decrypted, and it should be able to actually decrypt it, because we really didn't change much. We just kind of changed how it ends up working. All right. And so back into my Jupyter notebook here, I'm going to get rid of everything that was actually called, even these folders here. We do not need them. We don't need any of them, actually. We just need the modules themselves and the key. And I definitely do not need the import up here. And so there we go. Now what I'm going to do is I'll do kernel restart and run all, just to clear out some of the notes in there, and then move everything up, because this is going to be our final module. And there we go. And so let's delete all these with shift and select, or shift and up when you select on the side. Go to edit and delete cells. Edit and delete cells. Okay, cool. There's our encryption module. I'll go ahead and download this as a Python file, and we're going to go ahead and keep this. We're going to reveal it in the Finder or the File Explorer if you're on Windows. And then we're just going to drag this encrypt module over and change it from encrypt module to just simply encrypt. And then I'll get rid of all of the Jupyter Notebook related things in here that always come up as just notes that it's essentially made from a Jupyter Notebook. Cool. So now we have our encryption module ready. So it's time to take this encryption module and turn it into a pipeline that we can run at any time. The other thing is the actual folders that we're going to use for this. We might want to create them now, as in the output directory for our secure folder and the decryption directory for that output as well. Those things may or may not be included in our gitignore file. Now, I actually think that we will leave those things until we actually start using this module itself. So I'll leave those folders for a little bit, because in the pipeline, that's when we'll actually declare the folders, because our encrypt module doesn't actually care what folder you end up using. And I will say that we probably should have some checks in here that these are actually folders, not files, because it's possible that you do that. But even the input directory, that could be a file, but you would probably want it to be a directory because it actually loops through everything. So you could always get the parent of this if it is a file. I'll leave that challenge to you as far as how to do that. But this is a pretty straightforward way of doing encryption for an entire directory, especially now that it's a module, so we can reuse it. right, so now we're going to go ahead and make our encryption and decryption pipelines for this ignored folder and the encryption folders that will come with it. And so in this pipelines here, I'll go ahead and do encrypt.yaml. And so this is going to take in a few steps. So the step one, I'm not going to write it out just yet. We're going to go ahead and do our import. Step two, we're going to go ahead and actually, pass in our args. And then step three, we're going to go ahead and actually call our function here. Okay. So step one, we'll just go ahead and name it. And this is going to be pypyr.steps.py-import. And that's going to give us a n. And inside of here, we'll go ahead and do py-import. With the pipe, tab in a little bit and do from app.encrypt, or we'll just do from app import encrypt. Okay, so the next step was our args. So we'll give it a name of pypyr.steps.set. And again, we'll go ahead and do n. This time it's going to be a set. And we're going to declare to encrypt. This is going to be my key value pairs in here. So the first key is going to be our input directory. And that, of course, is app/ignored. Okay, so this input directory, or the pipeline itself, is going to be run on the root of our project here. So thus app/ignored makes the most sense. And then our output directory, let's just tab this in a little bit. Output dir is going to be app/encrypted. Okay, so no dash there. That's it. So I totally can actually have multiple items in here. That I am not going to do. I'm just going to keep one. And so the next part is to name it. So, step one, step two, last one is pypyr.steps.py. This is just a name of this actual running method. And so I'm going to go ahead and run !py. So this will call Python. We encrypted the module of encrypt, or we imported the module of encrypt. So we just call encrypt dot and then encrypt dir. And this is going to be the input directory. So how do we actually get the arguments that are coming in here? Well, that comes from for each. So for each can actually call from this right here. So this is a list of items. It ends up being a list of items with key value pairs in here. So this is a dictionary, if you will, where this can have multiple dictionary values. And so in here, I can actually call for each and then pass in that to encrypt here, right? So the only way for this to run this stuff is to have this for each. So when you do that, it will give you a variable of I for each iteration. So each one of these is assigned to the variable of I. That is a PyPyR thing. And then what we'll be doing here is calling each value, just like that. So the value, of course, is the input directory for the first one, and then the output directory for the second one. And that's it. So let's go ahead and run this with python-m, pypyr, pipelines, and encrypt. Hit enter. And now we get this encrypted folder here. Okay. So in our case, it actually didn't bring anything in. So maybe we have ignored as spelled incorrectly. It did create the folder, but now with it, the actual input directory correct, it runs through and we get our encrypted data here. Great. So that's a folder I actually want to keep in my GitHub repo. Okay. So I'm not going to add that one to git ignore. I'm going to go ahead and copy this entire pipeline and call it decrypt now.yaml. Paste it in here. So now I'm actually going to change these to decrypt, and we'll go ahead and say secured dir and output dir. That's fine. So the secured directory is going to be encrypted, right? So the old input directory. And now our output here, well, what is it that we want to call it? Now I could actually leave it in as ignored, but the problem with that is if I run this locally, it runs the risk of me messing up something here. So I'll go ahead and say decrypted as my output directory, and then we'll change the method as decrypt, and then also the for each loop. Okay, and so we'll also use our secured dir here. Our output dir is still the same place, and there we go. Simple enough. Run this again, and now run decrypt. Hit enter. Sure enough, there it is. So this one, I certainly do not want to check in, right? So let's go back to our gitignore file here and just do app and decrypted, save that. Now that one will not show up in my database call. I just want to add my cluster bundle and basically say, well, let's go ahead and grab the source directory here. So I'll say source dir equals to these two things here. And I'll say, if not source dir exists, then I'll set a new source dir as base dir slash decrypted. Okay. And so here we go, source directory. So now, of course, it's going to run all that and look for that decrypted data. Encrypted now, just to finish off this pipeline and to make this fully ready, we go into our Dockerfile, and we already have our entire app being moved over, right? So the entire folder is definitely going to be in there. And we actually already ran a pipeline right here. So all we need to do here now is run the pipeline of decrypt. Now this, of course, is going to assume that we have the correct environment variables, which of course right now we do not. But that's our pipeline. Now we just need to deploy this. It's going to be fairly straightforward to deploy it. So let's go ahead and start that process. Now we're going to go ahead and update our production environment with the encryption key finally. Now off the video, I actually made a few little changes. One of them being that I added the // to this entrypoint.sh. You can absolutely use the absolute path or just // depending on the working directory. Just a minor change, but something that we needed to do. And also in our entry point, I actually never called the app configuration itself. So be sure that you have both of those things changed before you go into production. So now on my virtual machine here, I'm going to go ahead and cd into proj and git pull origin main and just let that update my code. Then I'll go ahead and do sudo nano and .env and add in my encryption key there. Okay. So once we do that, we have the basis for our entire project to work. And so every once in a while, when you are updating a project, just simply do docker system prune -a -- volumes. And I'm not going to do it right now because it will make the build time a little bit longer. So I'll go ahead and say no. And so the reason for this is because once you start building things on a regular basis on your production environment, it will start to eat up room on that production environment. So pruning it is a good idea from time to time. It doesn't have to happen every time, but it is a good idea sometimes. But then the next time we actually run docker build -t AI-API with the file of Dockerfile period. After you prune it, this will take quite a bit longer because it's doing everything from scratch then. Okay, so in my case, I actually just built it, so it went pretty fast overall. But the idea here is if I messed up on my decryption, it should actually run an error. So if the environment variables weren't done correctly, that's what would happen. The next thing is I actually want to just jump in to the container itself. So -it AI-API bin/bash. Remember, this is kind of like SSHing into a Docker image. And I just want to call that entrypoint.sh command. The exact same command I have at the end of this Docker file, just to make sure that that's running. And it looks like it is, right? I don't have any errors now. And what's cool about this is it's not giving me any errors about Astra DB either. So that means that my encryption process did work in production as well, which is awesome. But the thing is, if I wanted to, I couldn't actually access this server, right? Because I really just ran a local version of that command. I don't have it exposed to the outside world at all. So let's go ahead and close this out, exit out of the container itself, go back into the virtual machine itself, and now we'll just go ahead and run docker run -- restart always, and then add the environment variable port. And in this case, I'll do 8001, just to show you the mapping part of things. Then I want to expose the outside world port to port 80, right? So in other words, the default non-secure port is port 80. So if I come in here and said 80, the browser is going to automatically go back to that port. But if I said 8001, it's going to look for that port, right? And so if I wanted it to be 8001, I would just say 8001 here, but I'm going to leave it in as 80 and then map that to port 8001, right? So the internal 8001. much like up here, we had an internal port of 8000 running. This is very similar to that. It's just it's going to map the external port that anyone can go to that port 8001. Next, of course, we're going to move it in detach mode with -D and then AI-API. We hit enter. Detach mode is how we're going to be able to restart this always. So with that, it should run and we should be good to go. So let's go back into our project here. Now I can't actually access it on 8001, so I'll get rid of that, but I can access it right there. What do you know? We are now in production. Now, one of the big things about this though, is you should have changed your encrypted file here, right? So if you were pulling my code up until this point, this encrypted file would not work. It would just not unzip. It would have that same AstraDB error. So that is something why you would actually want to at least import this to your own personal project and work off of that. So we already gave you a bunch of strategies on how to do that. But that's pretty cool, I think. It's now in production. It's now working. We could totally test this, and I definitely recommend that you do. But of course, I'm going to test it just by looking at the data set, and what do you know? There it all is, which is awesome. So this is now a production version of our AI as an API running and working. So the biggest question is, this was a lot of manual stuff. How do I make it a bit more automated, right? So on our actual production virtual environment, we ran a bunch of manual commands. This is not ideal. Now, part of the reason I actually wanted to work with pipelines in the first place was because of the automation, right? So it actually tends towards making this as automated as possible, especially with the encryption step. The downloading model step was also automated, but this could certainly be improved quite a bit. But the idea here is we want to use automation whenever possible. But when in the case of automation, we don't want to automate before we know how to do it manually, right? So we definitely want to know how to do it manually. So if our automations fail, we can actually go backwards. All right, so let's go ahead and talk about some of the considerations you should have when updating our code and our project. So what we would do is we'd actually clone this virtual machine, make changes to the clone, and then rotate things. Okay, so what do I mean by that? Jump into Linode. You would come in here, click on the side here and hit clone. Now I could absolutely make an image out of it like we saw before. I could totally create an image and do it that way as well. That might be an effective way also. But the idea here is we would clone this, and with the new clone, we would just power this on. Right, so let it boot up and give it some time to do that. Now, also with some of these Linodes, we would probably add in a private IP address. So we'd come in here and go to add private IP address right there. Now in this case, I actually allocated one while I was testing, which you can see down here. So this private IP address, the reason we would have that is so we can implement a load balancer. I'll show you that in just a moment. But while this is actually running, the cloning process then to get it to running takes maybe 5 to 10 minutes, which is why you didn't see me do it. But I can go ahead and copy this new endpoint here, this new IP address, and right now it's not fully running, right? It's not even accessible. So we do need to give it some time before it goes up completely. But once it does, it will give us the exact same information, the exact same data. So if we go into data set, all of it's running and it works identical to the other one. I didn't have to do anything extra. So the reason I show you this is because now I could log into either one of these, make some changes, and then eventually, I could even change the IP addresses. I can swap the IP addresses, but that's not efficient. What would be more efficient and better in the long run is to have a actual load balancer. So if we go into the node balancers here, this is where you actually create a load balancer in Linode. But the load balancer will do a couple things. One, it will distribute load across these virtual machines so that not one of them is handling everything. And then two, it will allow me to rotate these virtual machines a little bit more easy. Let's take a look at what I mean by that. Now you don't have to do this, just follow along with me. I'm going to call this my LB, and then I will not add tags at this point. I want to select the region, the exact same region that I have for my nodes. And then I want to scroll down to the backend nodes. I'll go ahead and say node-1, grab the IP address. Notice that these are private IP addresses. I had to have private IP addresses on both of these, something I did not do in the video other than show you the reference. Okay, so then node 2, and we come in here, and now we've got two different nodes. two different IP addresses, two different nodes, right? So the public IP addresses are these, right? That doesn't really matter that much, but now we've got a potential for a load balancer. I hit create, and this will take a little bit of time to boot up. But the idea here is we've got an IP address here now. So yet another IP address that will be booted at some point once the actual load balancer is fully up. So it will take a moment before this is actually able to receive data, but then also redistribute it to one of these, right? And so we could talk a lot about the actual instances themselves and a lot about load balancing. But if we look in here and go to dataset, now I see that I have this single IP address and it's going to all the data sets. And for all we care is this is working. Now in the back scenes and the actual load balancing itself, it's going to distribute the traffic to each one of these IP addresses. So if one of them goes down, this is like if we were updating it, one of them is going down. So what's going to happen is the node balancer or the load balancer is going to distribute traffic to the one it can actually access, right? So the one that's shutting down, we could kind of say like, hey, this is it being fixed, it's being improved, it's doing all those cool things. And then that way our service is not actually going to be interrupted. Now there might be one lag period for the node balancer because it will take some time for it to fully propagate those changes. But now this is virtually shut down, but the node balancer is still working. So our service essentially would still be up and working and have no major problems. Maybe, hopefully, assuming we did everything right. But at least that's a method on how you could do this. And of course, then you could actually delete this instance itself and then you're good. You could just work off of one instance still. It just does add a little bit of cost, but the cost is a huge savings in terms of keeping uptime, okay? And so that's just a quick and easy way to do that. Maybe it's not that easy. Maybe it's a little complicated still. I do recommend looking into more load balancer stuff if you are interested in that. But I will say now we have the ability to start automating this. And that's not something I'm going to do in this series, but let me know in the comments if you want to see it. The idea behind the automation would be to use GitHub Actions to run workflows very similar to the pipelines we were doing with Pypyr, and then using a tool like Terraform that will actually do the provisioning of our infrastructure, like as in turning on all of these instances here, and also maybe even adding a load balancer. It would also allow us to write scripts to pull all the code, run Docker install, Docker build, and then Docker run. All of those things that we did, cloning our repo, all of that stuff can be handled with a combination of GitHub Actions and Terraform. So I think it's like such an amazing combination, those two things, with a service like Linode to actually run it. And then the other part about Actions that's really cool that will better secure your applications is you can actually put the environment variable stuff in GitHub Actions. So you're not manually doing that at all because, well, we don't want to manually do anything, especially not hard coding, stuff like secret keys. But I knew I was going to mention all this stuff. So that's really the major next step in making this a lot more automation of a deployment pipeline at this point. But even without an automated deployment pipeline, we now have strategies on how we would go about updating any given instance and having little to no downtime. Okay, so one of the challenges, of course, would then be to turn this IP address into its own domain name. Now, the way I would actually treat this service itself, the actual AI model service, is I would make it a microservice to a bigger project that actually controls the domain and all that, and potentially even adding in other load balancers to help map and deal with some of this data like through Nginx. But that's really it. I mean, we've got a production application running. All of the things about it are running and working, I think, pretty reliably. It's just updating from here. How reliable do you want that to be? Now, if you're just starting out and you're just getting your feet wet and getting something like this into production, I don't think you have to worry about downtime. I think downtime comes when you actually have services that are relying on this particular service. Now, for your own edification, to get better at all these things, then yeah, learn how to build the automated pipelines, because doing things manually is how you actually end up causing a lot of errors and breaking a lot of things. But that's how I learned the most myself. When I broke something that was in production and I'm like, oh my goodness, I need to get this back up and live. So I worked super hard and learned a lot in a short amount of time. Now you might find yourself coming back to this video to do exactly that. This video hopefully illustrates some of the things that you need to consider when going into production. And also shows you how we do that final production. So if you got this far and you're able to do all of this, including the load balancer stuff, good for you. That's amazing. This is not something that many people know how to do from end to end. That is doing the machine learning part all the way to the web application part, encryption, and then also into production. So I'm proud of you if you got this far, and let me know if you did. I want to check out the things that you're building if you have some cool stuff to share. All right, so now that we've done all of those updates, I recommend that you shut everything down if you haven't already. That is deleting that node balancer and powering off and shutting down each one of these Linodes. You should have all the code to get these things back online if you need. But of course, I definitely do not want to have a $40 a month thing that I'm not using running. So be sure to do that too. Hey there, thanks so much for watching. Hopefully you got a lot out of this one. Now my challenge to you from here is to actually use a new data set, and ideally one that you created yourself. So to do that, you are going to probably want to scrape data on a schedule. I have a whole series dedicated to that, so check the link in the description. But the idea is once you have your own data set and you can make your own AI models, then you're going to be able to actually launch your own REST API service and potentially provide a lot of value to the world, because this ground of AI and machine learning is so fertile. So I do recommend that you try it out and really just push yourself to the next level of what's possible, or even what you think is possible, because I totally believe in you. Thanks again for watching. Look forward to seeing you next time.